Hello, this is John from KEVARprogramming.com, and in this tutorial we're going to look at how to use the wildcard with generic parameterized classes, or parameterized, however you say it. This is a quite advanced topic which you can definitely skip if you just want to get to grips with really basic Java, and in future tutorials we're going to return to some more perhaps more important topics. But nevertheless, this is a useful thing to know, and this seemed like a logical place to put it in this course. So let's take a look. And now, for the purposes of this tutorial, I'm going to create a couple of classes up here. Let's have a class machine, which of course implicitly extends object, because if you have a class that doesn't extend anything, in fact it extends the object class. That's object with a capital O. And I'm also going to have a class, let's make this some kind of machine, so camera will do, which is a kind of machine, and let's say camera extends machine. Okay, now we saw in the last tutorial some examples of parameterized classes, of generic classes that can work with any type of object, and you have to specify the type of object when you instantiate the class. So an example is array list, which if you want to store strings in an array list, you have these kind of diamond brackets, and you put the type of thing that you want to store in the array list here, which is string in this case, and let's call that list and set that equal to a new array list. And before Java 7 I have to say string again here as well, so let's just do that, and I'll add the import there for array list. Now that's pretty simple, but there's kind of something that tends to catch people out here regarding the passing of this to a method as a parameter. So let's take an example there. I'll create a public static void show list method here. I'm just making it static because we don't have an object of the class app. So to be able to call this method without doing new app, it's going to have to be static. And here I'm going to say show list, and I'm going to change show list so that it takes as its argument an array list of strings, just like this, and let's call that list as well. And now I can pass that my array list of strings, and show list could, for example, just iterate through the list and say for string, let's say just value in list, then I could just do sysout on that value like this. So that should all work, and if I add some strings here, list.add, let's say 1 and 2, that should do the trick, and I'll just run that and see what happens. So let's just save app.java. So there we go, it says 1, 2. So that's really straightforward actually. If you've got an array list holding strings or whatever, and you want to pass it to a method, it's really easy to do that. You just have to remember that the type includes the type parameter there. Now there's a bit of a complication here. Let's take a slightly different example. Let's make this an array list of machines. So I've got a machine class up here, and actually let's also give that a I'm going to right click in machine, and I'm going to go to source, generate toString, and let's just create a toString method here, and I'm just going to return something that lets us see that it is a machine. Let's say I am a machine, like that. So now if I change this to machine as well, I can now add machine objects in here. I could say new machine, and let's have 2 of them, although they're going to be identical. because machine doesn't have any instance variables at the moment, but that's fine. Now as long as I change this to machine as well, we have no problem. I can run that, and well, once I fix the errors, because yeah, this has got to also be machine here, and that should be fine. So let's run that, and there we go, we're outputting the contents of the list. Now supposing you have another array list here, which contains a subclass of machine, like camera. Let's give camera a toString method as well, so that we can distinguish camera from machine. And I'll just say here, I am a camera, and let's just copy this stuff, and I'll do Ctrl+Shift+F to format that, and let's call this list 1 and this list 2, and here I'm passing list 1. And now instead of new, and this has got to be list 1 as well, and whoops, and that down here we're going to have list 2. So now I'm going to pass new camera to this list here, like this, and then I'm going to just carry on as before, passing list 1 to this function. So this doesn't have to be list 1. So this is the same program as before, it's just that I've created another list and added cameras to it. Now that runs fine, just as before, but now the temptation is to think here, well, what if I want to pass a list of cameras to this method? Because the temptation is to think that, okay, because camera, sorry, this should be camera, because camera is a subclass of machine, then you sort of think, well, array list of cameras must be a subclass of array list of machines. And then you think, well, surely here I can pass list 2 to this method. This method accepts an array list of machines, so I should be able to pass an array list of cameras, shouldn't I? And that's where you have the problem, because in fact an array list of a child class type, or any, more broadly speaking, any parameterized class which is passed a type parameter of some child class type, is not a subclass of the same parameterized class with the parent type of class as its type parameter. So in this case here, camera extends machine. An array list of cameras is not a subclass of array list of machines, so you can't pass it to this method. But it would seem reasonable that we should be able to somehow pass, because with polymorphism means that I could happily add cameras to a list of machines, and you think, well, surely there should be some way that I could pass an array list of cameras here to this method, and in fact there is. Now the simplest way to do this is to say here question mark, and the question mark here is a wildcard. It's called the wildcard in this context, and you read this as array list of unknown type, or more broadly speaking, such and such a class of unknown type. And this wildcard means you can now pass an array list with any kind of type parameter to this method. So this line is fine. Now the disadvantage is that then you can only treat the items in the list as of being a type object, because object is the ultimate parent of all classes in Java. That's object with a capital O. So you can't now call any camera or machine specific methods, even if you pass in a list of cameras or machines. But this does allow you to pass any kind of array list in here. So this code is going to work. So it says I am a camera because I'm passing in cameras here, or of course if I pass in machines, I am a machine. And this works because the object superclass, it's a superclass of both camera and machine, and it has a toString method that enables system.out.println to work. So now the only way here you could call camera specific methods, let's say, or machine specific methods, is if you were to cast, as we saw in the tutorial, the tutorial on downcasting and upcasting. If you know that this is a list of cameras, let's say, you could downcast this object to a camera object, and then you could call camera specific methods. But when you get the objects directly out of the list, they're going to be of type object because you use the wildcard here, and you don't know, Java doesn't know what type of thing is going to be in that list. It could be any kind of type of thing. Now, if you're still with me on this, there's another couple of interesting things that you can do with these wildcards, and one is you can specify an upper bound to the wildcard. So let's say I want to pass to this method an array list of machines or an array list of any subtype of machine. And that could be useful because let's say I've got a machine, let's say machine has a method here, let's say public void start, and let's just put this out here and say machine starting. So machine has a method that we can call, and supposing I want to say, well, whatever we pass to this method, it's going to be some kind of machine. It's not necessarily going to be a machine, it could be a camera or anything that extends machine. You can use an upper bound on this wildcard, and the syntax for that is fairly intuitive. You say question mark extends machine, and of course I'm talking about array list and machines and cameras here, but the stuff I'm talking about here applies to any parameterized classes and any kind of child and parent classes. Now that's going to work just as before. It says I am a machine, but now I can actually get machine type values from my list. So if I save that, there's no error. And if I would do a get on this list, like list.get, I can actually get machines from that list directly, which is what I'm doing in this loop actually. So here I could say value.start. On the other hand, if I pass in a list of cameras, so that's going to work. It's saying machine starting. If I pass in a list of cameras, that's going to work as well. So it's calling the camera toString method, and it's saying machine starting because camera has inherited that starting method from machine, and I didn't override it in camera, which is why it's saying machine starting. But let's say camera has a specific method, a method that's specific to cameras, like public void snap, and let's say here sysout snap, this is taking a photo. Now I can't in here call value.snap because all I can call are machine methods, because the reason's clear if you think about it, because all Java knows is that this list that's passed in contains some kind of object that extends the machine, but it doesn't know which object. You know, the objects that extend machine here could have any kinds of methods, and Java doesn't know. It's got no way of checking what methods it has. All it knows is it's some kind of machine, so you can therefore call machine methods. And slightly less useful, but perhaps worth knowing about, is you can specify a lower bound here. I could say, let's say the wildcard, I can say super camera, let's say, and that means that whatever I pass to this method, let's call it showList2, whatever I pass to this method now has to be camera or a superclass of camera. And the trouble with that is superclasses of camera could have they don't necessarily have the camera methods in them. So again, when you iterate through the list, you're really back to having to treat these as objects. So the only value really, so I can't call camera or machine methods here, but I can like use the toString method, because even object has a toString method. So let's pass in here, I could pass in either list1 or list2, it doesn't matter, because list1 is full of machines which are a super type of camera, and list2 is full of cameras which is camera, so that this is kind of an upper bound, so it's saying that this could be camera or a supertype of camera, and this could be machine or a subtype of machine. So this is going to work as well. So my second method there, it works fine. It's saying I am a machine down here. But again, if you wanted to use specific methods of camera or machine, then you would have to know yourself what kind of type of thing was in this array list, and you'd have to cast downcast in this case to the appropriate type. Either that or use techniques like you could use get class or instance of, which we will probably look at in a future tutorial. So I know this is a pretty confusing topic, and I think I got through I don't know how many years of being a professional Java programmer, both a permanent guy and a contractor, without actually knowing this stuff. And it's only recently that I've looked into this, and this was only added, I think, in Java 5 or something like that. So this is not a vital topic, but if you want to know what the wildcard does, that's the answer. And let's just for emphasis here, let's just copy that and create a final version of that. Just use the wildcard by itself. So this code's going to be on caveofprogramming.com, and you can take a look at this and inspect it at your leisure if you want to. So that should work as well. Okay, and that's it for this tutorial. And we covered like basic usage of generics in the last tutorial, which is really vital knowledge, and this stuff really is just the icing on the cake. And in a future tutorial we'll also cover creating your own parameterized classes, but since that's something that you very rarely have to do, I'm going to leave that for a few tutorials down the line, and we're going to return to looking at some more basic fundamental things in core Java. So that's it for this tutorial. Join me again next time, and until next time, happy coding.